Hi everyone, I'm Cheryl. In this problem, we're looking for the unit tangent vector at a particular point. And then we're going to be looking for a set of parametric equations that represent the tangent line. Okay, let's start by getting the unit tangent at any point. So at any point, we're going to be taking r prime of t. So that's going to give me an I plus 2tj plus k. I simply differentiated my position vector. But in order to make sure that this is a unit tangent, I'm going to divide by the norm of that vector function. So I'll take the square root of the sum of the squares of the components. So 1 squared is 1. Then I'll have a 2t squared and another 1 squared. So that leaves me with my vector I plus 2tj plus k all over the square root of 1 plus 4t squared plus 1. So that's 2 plus 4t squared. So that will give me my unit tangent at any point. But I'm interested in what's happening at the point 0, 0, 0. All right, well, to find out what's happening at 0, 0, 0, I really want to connect this point with my parameter t. So let's go ahead and look at the original function. I know that t is going to equal 0, t squared equals 0, and t equals 0. If I match up the x coordinate with the x component, the y coordinate with the y component, the z coordinate with the z component. In all of these cases, I find out that t equals 0. So my parameter t equals 0 corresponds to the point 0, 0, 0. So now I can just find out what that unit vector is when t is 0. So I'll have I plus 2 times 0 times my vector j plus k all over the square root of 2 plus 4 times 0 squared. This reduces to I plus k all over the square root of 2. Okay, so that gives me my tangent vector, in fact, a unit tangent vector at the point 0, 0, 0. Now what I'm interested in is getting a set of parametric equations that gives me a line that is passing through the point 0, 0 and has the same direction as that unit tangent. Well, because it's a line, I know all of my parameters will have the form x1 plus a constant times t. That's true for each of the different parameters. And I know for the x equation that the x1 is going to be 0 because it's matching up with my coordinate 0. So I'll have 0 plus, now I need a. A is going to represent the direction. Okay? And right here I have the direction of my tangent vector. This one's a unit vector, but notice I really only need the direction. I don't care in this case whether it's a unit or not. So I can just use a to be 1. So I'll have 1 times t. So my first parametric equation is x equals t. I can do a similar thing for the y value. The y1, the coordinate is 0. Now I need a direction. Notice that there's no j component to my tangent vector, so it's going to be 0 times t. And so y equals 0 is my second parametric equation. Finally, for my z equation, z1 again is 0. And this time, the direction is 1 because my coefficient in front of the k is a 1. So that's 1 times t. And so I end up with x equals t, y equals 0, and z equals t as my set of parametric equations. I hope that was helpful. Thanks.